Good evening, ladies and gentlemen. Ooh. uh, Before we start, we would like to take a moment to thank our amazing instructors for being amazing mentors, role models, and friends. Um, this summer, as Jake said, we set out to replicate a paper that investigated racial bias in police use of force. So replication is very important. To quote the Open Science Collaboration, reproducibility is a defining feature of science. So a huge problem in research is that many papers are not reproducible. There are many reasons why a paper cannot be reproduced. For example, the code or data sets are not provided by the author, which means you're not guaranteed to be working with the same data. The methods could be unclear or difficult to parse through, which means you don't know exactly what to do with the data. And there could be p-hacking present, which means that that when a researcher, either by accident or on purpose, does questionable things to his or her data, to achieve a significant result to report. And we decided that if we're going to do a replication study, we should replicate a paper that people truly care about. So the paper we studied is by Roland G. Fryer. He's an economist at Harvard University. His main findings were that in non-lethal uses of force, blacks and Hispanics experienced significant racial bias, even when controls were present. But in lethal or more extreme uses of force, there were not significant. There were not racial bias present. So as you can imagine, this paper generated a lot of buzz and controversy, not only within the academic community, but also to the general public as well. This is the New York Times, and this is USA Today reporting on the paper. And this kind of highlights why it's important to evaluate the findings of scientific papers, because the public often takes a scientist's word as fact. So one important thing to note is that our goal was not to resolve the controversy of the paper, surrounding the paper and the issue as a whole, but rather just check his results. One way of looking at that is, if the result doesn't replicate, is there even any controversy present? So within the paper, there are two publicly available data sets: the NYPD Stop, Question, and Frisk data set, or SQF for short, which looks into police-civilian interaction from a police perspective, and then the Police Public Contact Survey, or PPCS for short, which covers police-civilian interaction from a civilian point of view. Key difference is that the Stop and Frisk dataset is exclusive to NYC, and the PPS dataset is a nationally representative survey. There were simple methods employed by the paper, counting methods and logistic regression. And it's a pretty detailed paper. It clocks in at about 110 pages. And if you actually look closely, the appendix is longer than the actual paper itself. But it appears that there's an ideal scenario present for replication. But is there a systematic way to approach this? Well, here are the three types of analyses. There is reproduction, which is when the data is the same as the original paper, where the code is provided by the authors, and that you get exactly the same numerical results and thus the same conclusion. But Fryer did not actually provide his code, so that makes reproduction impossible. So our main focus is replication, which is where we write code to try and get the exact or approximate numerical results and thus the same conclusion. We also did some extension, which is where we use data sets released after the paper was published, and try to achieve similar results and observe a similar trend so that we can reach the same conclusion. And our agenda was replicating stop, question, and frisk, the analysis on it, extending that analysis with maps and census data, and also replicating the PPS survey analysis. And now Romil will probably introduce you to the stop and frisk data analysis.
Thank you, Emeka. Stop, question, and frisk. So how many of you know what a stop, question, and frisk is? Pretty nice. So basically, it's an NYPD program that was created back in 2003 and is still ongoing. What is it exactly about? Well, if an officer suspects that civilians are related to criminal activity, they might stop them and question them and probably search the clothing for weapons or contrabands. The data is released every year and is available to the public, but have in mind that this is a one-sided report. In fact, Fryer's paper addresses the issues by focusing on use of force by the police and how it varies by race. We found potential shortcomings in the data at the high level. So, for example, the police race is not specified in the data set. And we only account for people who has been stopped in the past, so we don't know about others. Now we're gonna take a look at one of the simplest steps, which is like downloading the data and collecting and loading it to R, which is pretty simple. Well, not so simple. So we found a lot of challenges, like mismatching columns, like the naming convention was really weird, and different numbers of columns, missing columns, nonsensical and inconsistent values. I'm gonna show you a few examples in the next slide. For example, we took a look at race. We were exploring, and we were expecting to have white, black Hispanic, black, white Hispanic, Asian, and American Indian. But wait a minute. What's Mel doing there? Your race? Probably. Well, next example would be age. This is bizarre. How many of you know somebody who's older than 150? Well, I guess we have immoral people living in New York City. We also found replication issues. For example, the number of observations were different, not crazy different. In fact, was 2,000 more data points than Fryer's paper. But we also have coding variables issues, like the last mentioned, and civilian race, which he decided to actually code black Hispanic has black people, and only white Hispanic has Hispanic. That's his choice, and probably if we took a different approach, we should get like a different result, which is you're about to see in this table. This table represents Fryer results. He took the full example of the population, meaning like people who were stopped. 10% were white, 58% were black, 25% Hispanic, and so on. Age is based on the average, and they part down by race, so you can follow. Now we're comparing our data to his data. As you can see, mostly everything matched, with the exception of the Hispanic group, which is a little bit lower. Perhaps he did some filtering that he didn't mention in his paper. That's one of the possibilities. Now we're taking the whole table, which is 5 different categories. The category on top is the one that we just saw, and there are 4 more, like encountering characteristics, civilian behavior, and alternative outcomes. As you can see, everything matched, with one exception. Daytime. which was subjective. He actually didn't specify anything about daytime. So we actually went on and tried different possibilities, and we got it to match, not perfect, but something. We actually went on and create a plot of it, since he didn't introduce any visual in his paper. So as you can see here, the y-axis has hands pushed to the wall and so on. This means that hands is considered to be low intensity force, and as you go on, you have the most intensive force, which is paper spray and baton. In the y-axis, you have the proportion. As you can see here, white civilians are 13% likely to experience harms on them. However, if you look at the Hispanic groups and black population, you can see that the disparity is bigger. They have like 25, almost 20% chance to have harms on them. However, if the intensity of the force increases, we see that the disparity decreases. Now I'm going to pass the mic to Adnan, who's going to talk about the model.
Thank you, Roy. So Roy just talked about empirical averages and the differences we see in terms of proportions. But these differences are just about race. But are they? Maybe there are other variables that can account for some of these differences. So maybe there's one group carries more weapon than the other, and this could be the main factor, and race could be secondary. In an ideal situation, we'd have a controlled experiment, and all of the variables would be constant, we'll just only change the race. But it's not possible in real life, because then we'd have to deal with like real people, real crime, real stop and frisk. So we were kind of restricted to the observational data set that we collected. What Fryer did, that he constructed a model that accounts for as much difference as possible for this data set. So let's now look at the model. As you can see, the main outcome of the model is use of force. So whether force was used or was there a no use of force. And the variable of interest is race. So for a no-control model, would have race as the only predictor and use of force as the main outcome. But we want to know how it changes after we add like different variables. Do other variables actually account for some of the differences that we noticed? So we add different controls, like civilian demographics, encounter characteristics, civilian behavior, precinct, and year. Now we want to know whether there was any change or not. For that, we have to look at the results for Fryer and for us. So let's look at the tables. So the table at the top, that's Fryer's results, and the one at the bottom are our results. So what's going on here? So if we look at the first row of Fryer's results, we can see the first column, it says white mean, and the row says no control. So no control basically means we're using race as the only predictor. So the white mean, the number basically here is saying that 15.3% of white people that were stopped had some kind of force used on them. And the other columns that follow white mean are basically their odds ratios relative to the white mean. So let's focus on the second column, black population. So what do we see here? So this number is actually saying that compared to the relative white mean of 15.3%, the black population have like a 53.4% higher odds of having any kind of force used on them. So one of the things that we wanted to see out of the results is do adding different controls actually account for any of the differences. So now if you look at the second column for the black population, and we see after adding controls, the odds ratios are actually decreasing. So it is actually accounting for some of the differences. But it doesn't go down to 1. That means it can't account for all of the differences. So there's still some existing difference there, some disparity. Now we can compare Fryer's model to our model and see the results. So we can see the numbers exactly don't match up, but it's it's kind of similar. It's close enough. But the important thing here is that we see the similar trends. So we see the downward trend for our results as Fryer's results. So it means that it's going down, but it's not going down to 1. So there's still some difference. So one of the issues that we ran into was the sample size. So if you look at the very right column sample size, you can see a lot of question marks. What is that about? So Fryer actually only reported this one sample size. So it's supposed to change with adding controls. But that's what we found. When we added controls, the sample size changed. But for Fryer, it was just one sample size, and we were not sure what that was supposed to mean. Like, what sample size was it? No control or full control? So that was one of the discrepancies we found. So I've been talking about odds ratios, and what does that actually mean? And it's kind of hard to talk about. It's kind of hard to interpret. And how Fryer talks about it in the paper, it's basically he's talking about probabilities based on odds ratios, which is not that intuitive. So we decided to calculate the actual probabilities and see what the changes are across the race. So here's a plot of the difference in predicted probability by race. On the x-axis, we have all the races, and on the y-axis, we have the predicted probability of use of force. Now, this is a much clearer picture. We can see how likely a black individual is to experience any kind of force when he is stopped. And we can also calculate what's the difference between a black person having any kind of force used compared to a white person. So our findings suggest that the difference is actually 37.5%. So black people have 37.5% more likelihood of having any force used on them. But Fryer reports it to be 53%, and which is based on odds ratios. So that's another inconsistency we found in our results. So that led us to kind of evaluate the model, see how the model is actually performing. So how do we evaluate a logistic regression model? So the standard way to evaluate a logistic regression model would be to plot a ROC curve and calculate the area under the curve. So our data set was not a balanced data set, and AUC is a very balanced accuracy measure, so this was a good way to evaluate the model for us. So the highest measure for AUC is actually 100%. So we can say whenever we say there's force being used, there's actually force being used. And the lowest measure is 50%, so it's like randomly guessing whether force was used or not. We calculated the AUC, and we found the AUC was 68%, which is not great, but it's not terrible because it's above 50%. It's closer to 50 than 100, but it's not that terrible. So this low AUC suggests that the model is not really a good description of the reality of the data set. So we did one more thing. We decided to take out race from the model and see how that changes the AUC. Surprisingly, there was no significant change. It remained the same. So it potentially might imply that race probably doesn't have that much predictive power when it comes to the model. So from the takeaways from our analysis, we were not able to replicate the results exactly, but we recovered the underlying patterns. We can say that the controls don't account for the racial differences, not completely. But the caveat is that the model's performance is not optimal, it's not ideal. And removing race does not impact the model much. So now I'm going to hand over the mic to my colleague Harpreet, who's going to talk about some maps based on the SQF datasets.
So as Emeka previously mentioned, we are trying to do two things, replicate and extend. I will be talking about the extension. We decided to visualize stop and frisk data on New York City maps. And in order to visualize the data, we first decided to calculate the probability of any force used on arrays and given on the condition that they were stopped in a particular precinct. So the map on the left indicates the probability of all of the white people who were stopped in a particular precinct, what fraction of them were subject to any kind of force. And the same goes for the map on the right, but this is for all the black civilians. So if anyone's more likely, or the probability of them being subject to any force used is higher, the map's going to get a little darker. But there is slightly higher probability for the black civilians who are subject to any force used. But this still is a little unclear. We still don't get a very clear idea of the difference. And therefore, what we decided to do was calculated how much more likely were blacks subjected to any force used in comparison to whites. So to do so, we divided both the probabilities of the white and black civilians. And sadly, this map actually shows that black civilians were more likely to experience any kind of force in a given who were stopped in a precinct. The only exception to this is Astoria, and this can be shown highlighted as the green area there. So we could see that, okay, there was a difference between black and white civilians. Is there a different trend for another race, say Hispanics? So yes, we could actually still find out that Hispanics were more likely to be subjected to any force in comparison to white civilians. The disparity is still not as much as the one for the black civilians, but yeah, we still see that the map is darker. So that was for any force used, but the data set actually had different amounts of forces. So now let's look at how much force was used. Is there a difference between the level of intensity that might affect the color of the person? So what we did was we decided to split all the forces into two different intensities. One of them was low intensity and high intensity. And we use these intensities to calculate racial differences. The map on the left indicates the probability that of a low intensity force being used on a black person in a given precinct over the probability of a low intensity force being used on a white person who was stopped in a particular precinct. So we do see that blacks are more likely to be subjected to low intensity force compared to white civilians. Whereas on the map on the right, we see that there is less of a racial disparity between both the races. So when it comes to more high intensity forces, there is less of a difference. And this actually is indicated by if there is no difference, the ratios would be around 1. And if there actually is a difference, the ratio would increase and the map gets darker. So now that we looked at who was stopped on the basis of different forces, Eda will be talking about who actually gets stopped.
Thank you, Harpreet. So, as Harpreet said, Fryer's paper only discussed who has force used on them by the police, but we also wanted to look at, in an extension of his paper, another aspect of police-civilian interactions, who is the police actually stopping, and that might be very different. So we wanted to look at the stop and frisk data, and we can count how many people of each race are stopped, but we figured that wouldn't be so representative of the big picture, because we could have a situation like this. Let's say here are the people who are being stopped by the police. It looks like the purple people are twice as likely to be stopped as the orange people. There are twice as many of them. But maybe the actual population looks like this. There are lots of purple people, and very few of them are actually being stopped. And then maybe the orange people are experiencing more police bias. So we decided to bring in the census data. The US Census data shows the racial distribution of people in New York City, and then we could see how the racial distribution of the population compares to the racial distribution of the stops in that area. So we started downloading census data, Harpreet and I, and all was going fine, and all of a sudden we just got this error one day, in the middle of the day, that the website was down, the census website just wasn't working, and there was nothing we could do about it. We couldn't go on with our work. So Harpreet was great. she went and called up the census. She demanded that they fix it. She spoke to 3 different agencies, and we got it back up and running, and we were ready to start working with our data. So the census data doesn't split on the precinct level. We wanted to look at precincts because we're discussing police, and that was one of the most consistent ways that location was reported in the stop and frisk data. So John Keefe, the founder of WNYC Data News Team, had published a publicly available key that mapped census blocks to precincts. We used that to convert our data, and we calculated for every precinct how many people of each race there were. And then we were ready to start analyzing our data. So similar to the maps Harpreet was showing, we calculated stop rates for each precinct for each race. In other words, the number of people of that race who were stopped in that precinct divided by the number of people of that race who live in that precinct. On the left, we have for the black population, on the right for the white population, and it's clear that the map for the black population is much darker, indicating that they're more likely to be stopped. And if you look at the scales, it's kind of interesting because in most cases, most precincts, the black stop rate is greater than 1, which indicates that the number of black people being stopped in each precinct for many of the precincts was greater than the number of black people who live there at all, which was really pretty extreme. Those 2 gray areas on both maps are areas that we chose not to look at. The one in the middle of Manhattan is Central Park. We decided not to look at that because according to the census, it has a population of 25, which is like 1/100th of any other population. It's not a big enough sample size to make any significant claims. And then the other precinct that we didn't look at is in Staten Island, Precinct 121. It was only created in 2013, so 2010 census data just wasn't going to work with that. So like Harpreet did, we wanted to compare these 2 maps more easily, so we decided to divide the black stop rate by the white stop rate and visualize that statistic. That's what this looks like. This is the black stop rate divided by the white stop rate. So just to discuss the scale for a minute, if the black and white stop rates were equal, this value would equal 1, and then the precinct on the map would be a kind of whitish color, not the white around, but the whitish areas in New York City. If the black stop rate was much greater than the white stop rate, the area would be red, darker red indicating more of a disparity. And if it was biased, the police were biased against whites, if the stop rates were biased against whites, then the area would be green or blue. So we see that in general, it's hard to see the coloring on this projection, but in general, the areas are very red and orange, indicating that the black people are more likely to be stopped. The only exceptions are Central Park, which, as I said, is not really meaningful. And this precinct over here, you can't really see it in this picture, but that's around Jamaica area. Not sure why there was no disparity there. Just to get an idea of how extreme the disparity is, in this precinct, Precinct 1, which is around like Wall Street, World Trade Center area, black people were 90 times as likely to be stopped as white people using these stop rates. So I just want to put that in perspective and say that there's one caveat in the way we measured this. The census population is not necessarily representative of who lives in an area, but people who spend their days in an area aren't necessarily the people who live there at night. So this might not be giving us a perfect picture, like Wall Street, Central Park, areas like that for sure. The people there aren't necessarily the people who live there, so that could be messing with our numbers a little bit. We wanted to try to fix that issue by looking at commuting data and getting an idea of the commuting patterns in New York City and calculating it that way. And we actually found data on the New York City Department of Planning website that talked about where people commute to and from in New York City, but we couldn't really work with it because it was on the census tract level, not precinct level, and it didn't have any racial data in it. I'd like to turn the stage over to Cindy, who's going to talk about another data set that Fryer used in his paper.
Thank you, Etta. So now let's bring in a different perspective. So tonight I'm going to speak about the PPCS data, which was briefly mentioned earlier in the intro. So let's take a closer look at the PPCS data. So I would like to start off with why Fryer decided to use this data in his research paper and what this data basically provides us with. So unlike the stop and frisk data, the PPCS data provides us with a surveillance perspective of their interactions with the police. And so Fryer thought this was important to include in the paper because he thought it could reveal differences marked by police misreportings. And so I bet you're probably wondering, what is this PPCS data? Well, it's basically based on the Police Public Contact Survey, which is a nationally representative survey of civilians aged 16 and older. It provides us with the information of a civilian's perspective of their encounter or encounters with the police. And this data is collected by the Bureau of Justice Statistics, and it was first collected in 1996. And the latest year that this data was collected was in 2015. Fryer did only use the years from 1996 to 2011 in his research paper. And lastly, this data is publicly available on the National Archive of Criminal Justice Data's website, but you could also find it on the Bureau of Justice Statistics website as well. So when we were looking at this data, we noticed a few things that we thought were a little bit problematic. And so I would just like to briefly mention what they are, but in the next few slides, I will definitely get deeper into them. So the first one is that people fill out nonsensical answers. The second one is that people are less likely to admit to their own shortcomings. The last one is that people might not remember things as accurately as we would assume. So people fill out nonsensical answers. So there was actually a question in the code books and in the surveys that the civilians had to answer. And this question was basically asking, how many face-to-face contacts did you have with a police officer in the last 12 months? So as you can see, there's a column that shows us their responses. And 12 months, you would assume that is 1 year, 365 days. But people were writing down some really crazy answers. So you can see 600, 365, 350, which basically means that these people were having face-to-face contacts with these police officers at least like once every day, which is pretty bizarre. So the next one is that people are less likely to admit to their own shortcomings. So there was also another question in the surveys and in the code books that asked, at any time during this contact with a police officer, did you try to disobey or interfere? Did you try to get away? Did you try to push, grab, or hit the police officer? Did you try to resist being handcuffed, arrested, or searched? And so we kind of assumed that the people who would answer this question would kind of react like this. So this kind of explains why so many people did not report any of these things in the data. So besides those issues that we had earlier, we experienced some more challenges with the data cleaning process. And so we had issues with the PPCS data columns because a lot of them were spread out for the variables that Fryer used in his paper. We also had to make subjective decisions when categorizing these columns, and some of the variables that were used in this paper were actually missing. So one example that I like to bring up about the spread out columns is the officer race column. And so Fryer used this variable, but in each of the years, it was kind of spread out differently. So for one of the years, which is 2005, this variable was split up into two columns, which doesn't sound too bad. But then you look at years like 2011, where you had 12 different columns for this one specific variable. And so it was kind of like tedious to try to go through all of these code books, try to find all of these columns and put them together into one code so that they could all match. So here we go. So you can see so many columns. So the next one is subjective decisions. So we definitely did have to make a lot of subjective decisions. There was one variable which was called the type of incident variable that Fryer used in this paper. And so this variable was actually really interesting to deal with because we had to decide on labeling each of these reasons. So each one of these reasons was labeled as a traffic stop, a street stop, or some other type of stop. But Fryer wasn't really specific as to which ones were a traffic stop or which ones were a street stop or which one wasn't another stop. So we basically had to go through each one of these reasons for each year and try to figure out what he thought was a traffic stop and so on and so forth. And so, as I mentioned earlier, there was a lot of missing data. So Fryer was not specific about how the data was aggregated. Some of the years were missing variables that were used for the regression and for a lot of the summary statistics. And so, for example, 1996 and 2008 were missing income and population size. 1999 was missing the time of encounter variable. 2005 was also missing civilian behavior. And so as a result of this, the missing variables greatly affected the regression and our results. So after merging all of the years together, we found our case counts, but we ran into a case count discrepancy. So in the paper, Fryer reported a total sample of 426,000 observations. But our total sample that we counted was 409,678 observations. And so after spending many hours and many days of trying to figure out what went wrong and trying to fix this discrepancy, we came up with a pretty different solution. So we decided to email the data manager from the National Archive of Criminal Justice Data. And so thankfully she responded back to us, and she basically said that she was unsure about why there is a case count discrepancy. And she also conducted the count herself, and she reported that she got a number closer to our number. So that is pretty strange. And we were pretty puzzled on how Fryer reported more observations than the actual survey company. So the mystery of the extra cases still remains. I would now like to pass on the mic to Naomi, who will speak about the summary statistics.
So thank you, Cindy. So now I'm going to talk about the summary statistics for the PPCS data. So first, I'm going to start with this table. So what is this table? This table is practically showing the proportions that Fryer computed based mostly on these variables that belong to the civilian demographics. So in the first row, he's computing the proportions over the full sample. In the second row, he's doing the same, but instead of the full sample, he's doing it over just the white population. In the third one, he's doing it over the black population, and in the fourth one, he's doing it over the Hispanic population. So as Cindy mentioned, the data is supposed to be national representative, and this can be shown in this table. For example, in the full sample column, the proportions of white that were surveyed was 77%. The proportions of black civilians were 10%, of Hispanic civilians were 9%, and other was 4%. So now I'm going to show you, this is just Fryer statistics, so now I'm going to show you our statistics and see how things match. So here we have our statistics on the right-hand side, and we see that pretty much a lot of things match. However, there were some stuff that were not completely the same. Those are labeled as the red ones. So you see some disparities. They are not the biggest things. They are not that different. However, if we compare this part of the table to the stop and frisk data, we obviously see more than they experience. So now I'm going to show you the whole table and see how it goes. So as you can see, we have way more variables that did not match. Again, there were not really big disparities except for one or two. But again, if we compare this to the stop and frisk data, we see that it's very different. This brings us again to the subject of subjectivity decisions and how that might affect our outcomes. So I'm going to pick three variables and try to see what were the problems and go over them. So the first variable will be type of incident, the second will be time of encounter, and the third one will be the alternative outcomes. Interestingly, the alternative outcomes variable was not used in the regression for the model. However, he did not specify why he did make that observation. So the first summary statistics is type of incident. Here we have visualization. So as you can see in the x-axis, we are specifying which type of incident was it. It was a street stop, traffic stop, another stop at which the encounter between the civilian and the police occur. And the y-axis is just measuring the proportion. The street stop was practically the same as Fryer's result, and our results are just fall in the same point. However, for the other 2 points, the traffic stop and the other stop, they are very different. So there is a disparity there. So some problems that we encounter here, as Cindy mentioned, is that in the years 2011, in 1996, there were many variables. So we were forced to just make decisions on our own on how to categorize them. So despite following Friar's coding schemes, we were not able to replicate the same results. So the next one, the next variable is time of contact, in which we also have the plot, and the x-axis is representing if the time of encounter between the civilian and the police officers where it was during day or night, and the y-axis is just calculating the proportions. So here, both of them are different. Some problems that we encountered with this data was that in the year 1999 did not have any variable related to this. So all of the variables for the year were missing. Another interesting finding was that in the appendix for Friar, he coded this as 6 different variables, 3 for day and 3 for night. However, the only year that only was coded as that was 2011. The other years only were coded as day or night. And when we went back to the summer statistics, he had them calculated as day and night. So we have to go back and forth between our code and his paper and keep changing it. And this is similar to we found problems similar to the SQF data as for the time of contact day. So the third variable was the alternative outcomes, more specifically the proportions of civilians that were guilty of carrying any illegal items as per when they encountered a police officer. So in this case, we are measuring all of that just by race. As you can see in the x-axis is specifying which races, and then in the y-axis is specifying the proportion. This was the largest discrepancy we encounter. And as you can see, the standard errors are more visible in this case. So here we encounter a very large difference in proportions. So something to take into account of why this discrepancy happens is that subjective decisions are a very real threat to replicability. So now something that Friar didn't mention, but we still did, is we created this variable, the force-related incident. So we are basically separating groups by income and measuring the type of force and measuring by race. So something interesting is that as income increases, force reduces. However, something that keeps going is that blacks are more likely to experience force rather than whites. So now I would like to pass the microphone to my teammate Brenda, who's going to talk about the model regression.
Thank you, Naomi. So Naomi just mentioned summary statistics, which are empirical averages. But what if there was more, like Adnan mentioned? So Friar introduces to us another model. And in this model, we're predicting if the civilian reports use of force, and the outcome would either be yes, they do, or no, they don't. And that's based on civilian race, which is our variable of interest. So together, this is our baseline model with no controls. But now, what if we add controls? What if it wasn't just race involved? So first, we added civilian demographics. That's like income, age, gender. We then added civilian behavior, which, as Cindy mentioned, is anything that you would do to the officer. We added contact and officer characteristics, which was the incident types, time of contact, if it was day or night, and the officer race. And lastly, we added the year. Now, in order to use the model, we had to filter out the data to include only people that had face-to-face contacts with a police officer. And that reduced our number of observations from about 400,000 to about 60,000. So let's take a look at the results of our model. So here we have a comparison of Friar's results and our results. And if we look, we first started off with no controls, and then we added civilian demographics and counter characteristics, as explained before. But if we take a look to the side where we show the sample size, Friar started off with about 59,000 sample size. And we're not sure if that was with no controls or if it was with full control. But when we ran our model, we started off with about 60,000. And as you can see, when we got to like encounter characteristics, we have like a quarter of the data left. And so overall, we can see that like the numbers don't really match. But like looking at the black population, there's still the same trend. They still have high coefficients that decrease, but still don't get to 1, and so the odds are still higher for blacks. But like Adnan mentioned, all these numbers, what do they mean? It's hard for me to interpret, and I imagine it's hard for a lot of you to interpret. So let's look at it in a more simple way with probability. And so I created this plot with the probability. And as you can see, on the x-axis, we have the civilian race. And on the y-axis, we have the predicted probability of force. As you can see, whites have like a 2% more chance of experiencing force, and blacks have about 5.5% chance. And so Friar actually mentions in his paper that blacks are 3.5 times more likely to report use of force by police in an interaction. And we're not sure if that's odds or if that's probability. But looking at this plot, we came up with that blacks are 2.7 times more likely, and that's, well, if it was odds or not, or probability, it's a difference. And so let's take a look at the performance of our model. So we used area under the curve because that's more of a balanced accuracy measure. And looking at this plot, if the area under the curve was 100%, that would be like perfect. If it was 50%, that would be equivalent to guessing. In our case, we have an area under the curve of 78%, which is okay. But now, what if we run the model again without race? We got now the area under the curve to be 74%, and that is a difference. And so I think that race maybe does play a role in predicting use of force. So we spoke a lot about the PPCS data, but what can we take away from it? Friar's results did not replicate exactly, but the underlying pattern we did find, which was that the controls don't account for racial differences. We didn't reach 1, on the odds, but the odds are still higher for blacks. Also, there was a caveat that we had a lot of missing data which eliminated many observations, and so the model doesn't really capture everything that's going on. And with that, I'd like to conclude and talk about what we could take away from research replication. So we pretty much had the most ideal scenario. We had public data, simple methods, and extensive documentation. But actually, it was much harder. I mean, originally when we got this project, we thought it would take us like 2 days, no big deal, we can do this. It took us 4 weeks. And also, it's really important that papers often leave out important details, and that's where we get into the issues that were mentioned before of subjective coding and missing data. Another thing is that releasing data and code are key for reproducibility, because otherwise it takes a lot of effort to clean the data, to recreate it, and we'd have to spend a lot of time of what we did. And finally, it's important to think critically about easily misinterpreted results. So as we mentioned before, we said that Friar said that blacks are 53% more likely to experience use of force. We still are not sure if that's odds or probability. We tried to simplify it for us to understand it, but again, we have to think critically about these results. And I just want to go back on the point about releasing data and code. We have a major contribution, especially for all you researchers out there. We hope that you're going to publish a lot of papers with our clean data set that we worked hours on. But it's now open to the public for anyone to use. It's a hard work effort of all of the team members here, and it's available on GitHub. Thank you, and if everyone would like to come up. Well, if anyone has any questions, we are here to answer.
I'll add one thing before you get to questions, which is that I got a heads up that the building might do a fire alarm test at 6:45, so we might have a very abrupt end to questioning. That's happening.
That might be
They'll be around afterwards, but have at it.
Yes.
Did you guys ever contact Fryer?
We wanted to. Trust me, we wanted to.
We have an email out to him now.
You have a draft, actually.
We have a draft, yeah. We were hoping he might just randomly show up here. Any other questions?
I have a more technical one as well. So, when you were doing the division between like low intensity and high intensity force, I forget which speaker was talking about that part of the presentation. Right? How was that
Yes.
demarcation made? Like, how did you guys decide what you were going to categorize as? How did you?
Yeah,
Like
that's
that one.
actually interesting because first we thought of the same too, but actually that was Fryer who did that, and each of the labelings for the different intensity of force, like the kinds of forces, like being handcuffed, having a weapon drawn at you, they were all actually part of the reporting process. That's how they were labeled, and Fryer actually split them into the intensity levels that way. Yes, because another reason that we also split the intensity levels was that because there were not a lot of data points for the high intensity levels. So in order to visualize our data better and get a more significant answer, we decided to go with what Fryer did. But thank you. Oh, any other questions?
Adding to that. Another reason we chose to do what Fryer did is because there's a lot of plots on the paper that actually corresponds to different levels of intensity, like different levels of force that was used. So we had to do a lot of cleaning, and we worked on some of them. Some of them turned out to be not that significant. So, but we had to do it for the overall process. That's why we kind of did that split.
Yeah, you showed that in your replication that you had pretty much the same results regarding intense force by race, that the difference tapered off to almost zero in the end, right? Do you have an interpretation why this should be the case?
For the stop, question, and frisk.
Yeah, when you showed that for low intensity, it was quite different by race, but as you get higher and higher intensity, the difference became smaller. And
Yes,
smaller.
so that was one of the hypothesis of Fryer. So Fryer said that when he actually analyzed the data set, he saw that when it's like low intensity forces, there's more disparity, but high intensity forces, there's not a lot of disparity. So he concluded it's because how police uses force, like how it is like for stop and frisk, it's more common to use like handcuffs, or like pushing to the wall. That's like a very common practice than to use like a pepper spray or like a baton. That's like really extreme. So very, very small portion of the stop that were made had like extreme use of force.
Could it be possibly because in extreme use of force by the police, the situation clearly requires it? In other words, it's not a question of being subjective any longer?
Yeah, I think so. Yeah, that's a great point.
To add on to what he said, Fryer actually does look closer into higher intensity uses of force through other data sets, but they were constructed specifically for this paper and are not publicly available as a result. Was that a question back? No?
That's basically so my question was, I know that you guys were mainly trying to replicate Fryer results, but did you experiment with any other models beyond logistic regression to see if you can get like better predictability?
We mostly tried to replicate, and so we used the same logistic regressions. However, there were times in Fryer's paper he separated by use of force, and so we had more of like the lower intensity forces running a model just based on that, or on adding more higher intensity of forces. But we mainly replicated according to what he did. But again, we also, we tried to take out race as a predictor, and we saw like the area under the curve for both stop and frisk and for PPCS. And so that was a little bit of, reaching out beyond the paper. And we saw, the differences. But any other questions?
All right.
All right.
Thank you, guys.
Thank you all for coming.